find the interval or intervals where the function is increasing and where it is decreasing. So let's have this example: y equals to x squared minus 9 raised to the power of 2. So for first derivative test, we'll get its y prime first. So we'll just evaluate first. So x raised to the power of 4 minus 18x squared plus 81. So we get its y prime is just equals to 4x cubed minus 36x. So we'll equate it to 0 afterwards. So we'll have 4x multiplied by x squared minus 9. So the first root is just equal, so we'll equate 4x to 0. So 4x equals to 0, x is equals to 0, and x squared minus 9. So x squared minus 9 equals to 0. So x squared is equals to 9, and x is equals to square root of 9, then x is equals to positive and negative 3. So this is now our critical points. So after this one, we'll plot a number line. So we'll have, let's say this is negative 3, this is 0, and this is positive 3. So we'll have a line here to separate its boundary. So this is an x is less than to negative 3. This is x is greater than negative 3 but less than to 0. This is x is greater than 0 but less than to 3. And this is also x is greater than 3. So after this one, we'll test its value. So sub this one. So after this one, we will have this y is equals. So let's equate this to y. So this one, this equation, 4x cubed minus 36x, right? So if we will pick a point here that is x is less than to negative 3. So at x is equals to negative 4, at x is equals to negative 1, at x is equals to 1, and at x is equals to 4, right? So having here, so at x is equals to negative 4, at x equals to negative 1, at x is equals to positive 1, and at x is equals to positive 4. So we'll have 4 multiplied by negative 4 cube minus 36 times 4. So minus 36 times 4. We'll have 4 multiplied by negative 1 cube minus 36 times negative 1. Again, we'll have this also 4 times 1 cube minus 36 times 1. And then 4 multiplied by 4 cube minus 36 times 4. So by using calculator, we'll calculate these uh, values of the y. So we have 4 multiplied by negative 4 cube minus 36 times 4. So we'll have a negative. Sorry, it is negative. So negative 112. Negative 112 for negative 1. So let's say for positive 4. So it's positive 112 for negative 1, negative 1. So positive 32. And for positive 1. So positive 1 is negative 32. So we'll plot this one. So the negative are at x equals negative 4 and 1. So negative 4 and 1. So this is it is negative. So this is negative and this is also negative. And the positive are x equals negative 1 and 4. X is equals to negative 1 and 4. So this is positive. This is positive. So after this one, we'll conclude that the increasing will be the positive interval. So increasing at, so what are the positive? Negative 3. So x is greater than negative 3 but less than to 0. And x is greater than 3. So x is greater than 3. For decreasing function interval, so we have x is less than to negative 3 and x is greater than 0 but less than to 3. So x is greater than 0 but less than to 3 and x is less than to negative 3. So this will be now our final answer. So let's check if our answer is correct. So let's check if our answer is correct. For increasing, x is greater than 3 and x is greater than negative 3 but less than to 0. So for increasing, it is checked. For decreasing, x is less than to negative 3 and x is greater than 0 but less than to 3. So our answer here is correct. So that's all for this video.